Hello, this video demonstrates the Clarinox Bluetooth stack running on the Renesas S7G2 HMI board interface with the CC2564B dual-mode Bluetooth chip. We'll be able to debug via the Clarinox debugger running on the PC and interface with the CC2564B chip through the use of dual UART interfaces. The upcoming sections will show how to set up the debugger and how to run either the Bluetooth SPP or Bluetooth BLE applications. For this first demonstration, I will be using Clarinox BLE peripheral application. With the device already connected to the debugger, I'll go ahead and reset the board to load up the application. When the menu appears on the virtual console, I'll select option 1 to initialize the Bluetooth stack. This process will download the firmware onto the board and will take a few seconds to do so. Once the initialization is complete, we can start advertising our signal by selecting option 3 from the menu. Now on the remote side, I'll be using an Android phone with the NRF Connect app, which will allow us to scan, connect, and browse for any nearby Bluetooth devices. I'll just need to tap on Scan, and you'll be able to see our device appear on the screen. I'll just tap on it to connect, and the console screen will give us confirmation after we've successfully established a connection. Now I'll tap on Unknown Service and select the fourth option down, which is Characteristic Handle 8, as it supports both read, write, and notify properties. The app gives us the option to write some values to our device by selecting the up arrow icon on the corresponding characteristic. I'll just type in a random value and hit send. Now you'll see the same values appearing on the virtual console screen. Likewise, we can also read values sent by the console by enabling notifications by tapping on this last icon with the 3 arrows. Now from the list of options on the console, I will now select option 5, which is write local characteristics, and then type in 8 for the characteristic handle. You'll be prompted to enter some text to send out. Now you'll see those characters appear on the phone screen in both its ASCII representation as well as its original value. So I have now demonstrated that I can receive data as well as transmit data, and with that I conclude the first half of the demonstration showcasing the BLE peripheral application. We'll be able to debug via the Clarinox debugger running on the PC and interface with the CC2564B chip through the use of dual UART interfaces. Before running the application, we need to configure the Clarinox debugger. To configure the UART interface connected to the Clarinox debugger, select Configuration, which is found under the Connection menu. Make sure you have selected the correct port number to connect to your device, which you'll be able to confirm through your computer's device manager. You'll also want to make sure that your baud rate is set to 460/800. Once you have the correct configuration, go ahead and click OK. Connect to the device by pressing the play icon and choosing the UART interface from the window that pops up. Let's go ahead and run the application, which has been preloaded onto our board by pressing the reset button. You'll see the debug logs appearing on the Clarinox debugger. On the virtual console window, you'll see the initial Bluetooth menu. Select 1 to initialize the Bluetooth stack and wait for the initialization to complete. Let's make the device discoverable and connectable by selecting option 4. I'll be using an Android phone to run this test, so I'll need to open up this phone's Bluetooth window and scan for the device. You can see the device appearing on the screen. Select the device to make an initial pairing. The console will request confirmation that the device will be paired. Simply press Y to continue. Confirm the passkey on your phone, and with that, the pairing process is complete. I will be using Bluetooth SPP Pro app to make a connection between the devices. Before scanning for any devices, select option 6 to make the device discoverable. This will allow the app to detect the device. Select the device once it appears on the screen, and then select the option to connect. Now that the device is connected, we can send some text by selecting the byte stream mode option. Type your message and send it to see it displayed on the virtual console screen. Now I'll do the reverse by sending data from the demo app to our Bluetooth connected phone. To access the necessary features to send data, I'll have to go to the Connected Device menu by selecting option 8. If I were not already connected to the device, I would have to follow through with the first few steps shown in this demo. I'll press option 2 to send a message to the phone. And there it is. We can also send a huge block of data to find the speed of the connection. I'll do that by selecting option 3. Give it a few seconds to transmit the data, and when it's done, you can see that the speed is 5,000 bytes per second. Well, this concludes our demonstration. Thank you for watching, and check out our website for more information on our products.